Alright, so now I'd like to show you a large collection and the effect that indexing can have on the performance. I'm going to start the Mongo shell here, and I'm going to use the school database, and in particular the students collection. Now this is similar to what we had in the previous lessons. I'll show you a document from it. You can see that we have here a student ID for each record. There's actually also an underscore ID, which is a BSON object ID. And then there's an array of scores, and then there's a class for each student. Now, I have inserted 10 million records into this collection. And this is a pretty fast computer. This is a recent iMac, actually has a solid state drive and a bunch of memory. And I've been playing with the collection, so it's probably cached in memory. So let's see how slow it is to find something in the middle of the collection, or really anywhere in the collection. So let's go look at db.students.find, and let's look at student ID 5. Student ID 5 should come up pretty early in the collection. But because I'm using find and not find one, oops, sorry about that, little typo. Because I'm using find and not find one, even though it's going to find that record pretty early in the process, it took a couple of seconds to find the object, like 2 or 3 seconds. Now, if I did a find one, where the database could be satisfied by the first one it finds, then you'll see, whoa, that was really fast, very fast. And if I did a find one on the record 300,000 or 400, let's say 5 million, 5, 1, 2, 3, 4, 5, 6, that should be fairly slow because it has to go through the entire collection, or half of the collection to find one. And if I do a find, which is always going to search the entire collection because there could be more than one, we're going to get to the slowest case again, where it has to go through the entire collection to make sure that there's not more than one record with student ID 5 million. Let's say we wanted to put an index on this and make it faster. We can do that. This is how we're going to do it. So we're going to call the ensure index command, and we are going to give it the field, the key that we would like to index on, and we're going to tell it that we want to do it in ascending order. So let's go back through this, and so you can see each part of it. db.students, students is the collection name, ensure index, and then asking to put the index on student ID and make it ascending. So we're going to do that in real time. We're going to wait and see how long it takes to index those 10 million rows. Now right now the database is actually going through and it's looking at every single row and it's building an index for every single row. So this could take a couple of minutes. We're going to skip forward and wait in the video and get to the end of it so you're not having to wait for it. Okay, some time has elapsed now and the index has been created. Overall, it took about 2 or 3 minutes to create that index. So let's see how much faster it is to query the database now that the index is created. So we're going to do the same find we did before, same find command. We're going to look for a document with student ID 5 million. We're going to pretty print it. And we expect this to hit the index because student ID was the key in the index. So let's run that. Wow, that was fast. So you can see it came back immediately. Before we had the index, it took up to 5 or 6 seconds to do this query, but now that we have an index, it's immediate. And you can see that if we call it with 7 million, also extremely fast. But if we make a query that can't hit the index, like something that asks for everything with class of, well, we could say class of 7 million. There isn't any class with 7 million. Well, that won't matter because it can't know that. And you can see it's going to take a long time to tell us there's nothing. So indexes are really important in terms of the performance we get from the database. Let's look at that ensure index command again. So in that ensure index command, we called it with student ID :1. Now if we wanted to include the class, we could have included it somewhat like this. And in this case, it's a compound index, which is going to be made up of student ID, comma class, and I've decided to make the student ID ascending and the class descending. So ascending versus descending. So it doesn't make much of a difference when you're searching, but it makes a big difference when you're sorting, because if the database is going to use the index for the sort, then it needs to be in the right order. Now we can give, if we had other subparts of this document we wanted to index, we could continue. We could make it a three-parted index if we wanted. Of course, it takes more space and a little bit longer to build it when you do writes. Now, in terms of using the index, if I had an ID, an index on student ID, comma class, and I specified just the class, well, it couldn't use the index because it needs to be a left subset of the fields. If I specified student ID and class, I could use the index, and if I specified just student ID, I could use that index. Okay, let's do a quiz. So, please provide the Mongo shell command to add an index to a collection named students, having the index key be class, comma, student name. Now this is very similar to what I just showed you, but I just wanted to get you into the practice of typing these ensure index commands so that you're used to doing it in the shell.